A neural network-based information retrieval system needs a large training dataset made up of query document pairs to perform well. Several papers aim to build a neural information retrieval model using MS Marco as a training set, which is a large query document dataset extracted from Microsoft Bing search engine and apply it to new domain, a setting referred to as zero shot. However, these models still perform worse than traditional BM25 method in various domains. And since it's based on the web search data, it has limitations in covering a variety of real-world search scenarios, such as building applications using user data or multilingual searches. So the following question may naturally come to mind. Is it possible to train dense retrievers without labeled data, only using raw text dataset? If we can create effective search model without a large labeled dataset and just using a raw text data such as Wikipedia, it can save a lot of time and cost involved in dataset creation. It could also be applied to a wider range of fields considering real-world search scenarios. This paper, Contriever, proposes a method with two key components to achieve unsupervised training with only raw text data. And the two components are how to build positive pairs and how to build negative pairs. First, I will explain how they built the positive examples. To begin with, I need to explain the inverse closed task proposed by the earlier paper to pre-train retrievers. It creates related pairs by using part of a raw document as the query and the remaining part as the key. Here, given the document with tokens W1 to Wn, a part of the document, WA to WB, becomes the query, while the tokens from the rest of the document become the key. And since query and key are from the same document, their contents are somehow related and can work as a positive pair. However, the model that is trained with these query key pairs still lag behind BM25. In Contriever, they use independent cropping to make better positive examples. This involves randomly selecting two parts of the document, one to use as the query and the other as the key. Independent cropping seems very similar to inverse closed task, but has two main advantages. First, both queries and keys are contiguous subsequences, so those samples are symmetric. Therefore, when training the model, both queries and keys follow the same distribution. It ensures the models can easily match relevant queries with keys because they're encoded in a consistent way without one being biased toward a different structure. Second, independent cropping leads overlap between the two views of data, and this encourages the model to learn exact match between the query and key, just like BM25. Next is about building negative examples. In-batch negatives use other samples in the same batch as negative examples. For the dense retrieval model to perform well, this method requires a large batch size, which needs a huge memory for training, making it challenging to train the model in real-world situations with low computational resources. To solve this issue, Contriever uses a method called MoCo, which has been previously used in the field of computer vision. Here is the overall illustration of MoCo. Representations of positive sample K plus, query Q, and negative samples K1 through Kn are trained by the following info-NC loss. One big difference between MoCo and in-batch negatives is how they get negative examples. Instead of using representations in the current batch, MoCo stores representations from previous batches in a huge queue and use them as negative examples. During training, backpropagation is applied only to the query network. This is because updating the key network by backpropagation would cause a sudden change of the representations in the queue, disrupting its consistency and eventually slowing down the learning process. Also, copying the query network directly to the key network would cause the same result. Therefore, in Moco, the key network is designed to slowly follow the query network. In Contriever, M is set to 0.99 so that the representations in the queue changes slowly, keeping its consistency. With this approach, you can train a dense retriever without needing a large batch size while using enough negative examples for training. Now let's look at the experimental results. First is the fully unsupervised result on the comparison with the models that did not use any labeled data such as MS Marco for the training. In the bare benchmark, which evaluates the zero-shot performance of retrieval models, it outperforms BM25 on 11 out of 15 datasets and showed a significant performance difference compared to other dense retrieval models such as ReLIM and SimCSE. The reason it slightly falls behind BM25 on average is due to the TreeCovid and Touch 2020 datasets. The model performs worse on TreeCovid because the data used to train the Contriever was created before the COVID-19 outbreak. As for Touch 2020, it includes very long documents, which are not well suited for dense retrieval models. Next, since other state-of-the-art retrieval models such as DPR and Splate was trained with extra labeled dataset, Contriever was additionally fine-tuned with MS Marco to compare with other models more fairly. And here is the result. It shows state-of-the-art performance in recall at 100, which is a good metric for evaluating the first stage retrieval performance. This is another table using the NDCG at 10 metric, which is suitable for evaluating the final retrieval results. We can see that Contriever, combined with a cross-encoder, achieves the highest performance. Today, we explored the possibility of training a dense retrieval model without using a large labeled dataset. Even with fully unsupervised learning, Contriever achieved results close to BM25, and when fine-tuned with MS Marco, its performance improved even further, showing the state-of-the-art performance. That's it, and thank you for watching this video. Stay tuned for the more exciting topics coming soon. See you in the next video. Bye.